From your phone and laptop to electric cars and flashlights, batteries power nearly everything around us. They've become such an essential part of modern life that it's easy to forget how incredible they really are. But how does a battery actually store energy? Let's explore how this compact powerhouse works. At its core, a battery is a device that converts chemical energy into electrical energy. It does this using a clever combination of materials and reactions inside. Every battery has three main parts: the anode, the cathode, and the electrolyte. The anode is the negative side, the cathode is the positive side, and the electrolyte is the medium that allows ions, tiny charged particles, to move between them. When a battery is connected to a device, like your phone or a flashlight, a chemical reaction begins inside. The anode releases electrons through an external circuit. That's the wire or pathway powering your device. At the same time, ions move through the electrolyte from the anode to the cathode. Because electrons can't pass through the electrolyte, they flow through the external circuit instead, creating an electric current. This steady flow of electrons is what powers your gadgets. Let's take a common example: the lithium-ion battery. It's the type used in most modern electronics and electric vehicles. Inside, lithium atoms at the anode release electrons and turn into positively charged lithium ions. These ions travel through the electrolyte to the cathode, while the electrons flow through your device, doing useful work. When the electrons and ions reunite at the cathode, the chemical reaction completes. This process continues until the materials in the battery can no longer react, meaning the battery is dead or discharged. Now here's the amazing part: rechargeable batteries can reverse this entire process. When you plug in your phone, electricity from the charger forces the current to flow backward. The electrons move from the cathode to the anode, and the lithium ions follow through the electrolyte in the opposite direction. The chemical reactions reset, storing energy again for later use. That's why you can use a lithium-ion battery over and over. It's like a reversible chemical engine. Not all batteries are rechargeable, though. Alkaline batteries, the kind you might find in a TV remote, are designed for one-time use. Once the internal materials are used up, the chemical reactions can't be reversed. Rechargeable batteries, like lithium-ion or nickel metal hydride, are built with materials that can handle the stress of repeated charging cycles. The voltage of a battery, the strength of the electric push, depends on the materials used for the anode and cathode. For example, a typical AA battery produces about 1.5 volts, while a lithium-ion cell produces around 3.7 volts. Larger devices, like electric vehicles, simply combine many individual cells into a pack to get more power and longer range. Batteries have come a long way since they were first invented over 200 years ago. Today's scientists are developing new types of batteries that charge faster, last longer, and use more sustainable materials. Solid-state batteries, for instance, replace the liquid electrolyte with a solid one, making them safer and more energy-dense, a game-changer for electric vehicles and portable devices. So, the next time you plug in your phone or drive an electric car, remember, inside that small battery, countless chemical reactions are happening, releasing controlled bursts of energy that power your world. It's a perfect blend of chemistry and engineering working silently behind the scenes. To keep learning how modern technology really works, don't forget to subscribe to my channel How Things Work and comment the next topic you want to learn.